All right, guys, we are almost to the end of our numbers and operations unit, and we need to do one more thing, and that is convert our rational numbers to decimals. So you have this notes page, and let's get started taking some notes and talking about converting decimals. So a terminating decimal is a number whose decimal form has an end. Okay, so end goes right there, an end. Terminating, I'm going to get me some colors right here going. Terminating means to stop. So I'm going to kind of just shade that red. Terminating means it stops. It stops. It has a 0 remainder. It will eventually get you to a 0. All right, so it ends and does not go on forever to infinity and beyond. The last decimal place of a terminating decimal can always be named. So looking at these four, let's look at what is the last decimal place. Well, right here we have this 5 is the last place, and it is in the 10th place. Okay. Our last decimal place here is the 3. This is the tenths, hundredths, thousandths. All right. The 8 is in the ones place. And we could also say that this is 0 tenths, because you can put a decimal there and there's a 0 in the tenths place. Keep in mind the decimal always is in the back pocket of a whole number. And then this 9 right here is in the hundredths place. Okay. So that is a terminating decimal. I'm going to go ahead and come right here. I'm trying to watch, make sure I don't get out of the screen, but I'm going to just kind of come right here and shade that red like a stop sign. Make that red like a stop sign. Terminating decimals, stop. So our terminating decimals stop. So what would be the opposite, or what's next? What's after terminating? Well, we have repeating decimals. And so repeating, I'm going to just make those blue just because there's not enough. Repeating decimals are going to, what do you think they're going to do? They're going to repeat. Okay, they're going to have a repeating pattern. Just going to shade this blue so we know we've got red for terminating and blue for repeating. So let me get me a blue. Okay, so a repeating decimal is a number whose decimal repeats a predictable pattern forever into infinity. And Buzz Lightyear would be so disappointed if we didn't say, and beyond. In honor of good old Buzz, we'll put that right there. Infinity and beyond. All right. Just so that I know that you have watched this video, I want you to come down to the bottom right corner of your paper and circle that in S18. Just circle that in S18, and I will know that you have watched this. There'll probably be something else in there somewhere for you to do. All right, a repeating decimal may be written in one and two forms. I want you to mark out in black, because this is not true. Take something. We're not ever going to show a repeating pattern like this. Ever, 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 ever. And it's because when you get to 8th grade and you're doing irrational numbers and you have numbers that don't repeat, that is how, so we're just going to scratch that out. We will never, ever, ever, ever show a repeating decimal like that. We will always show our repeating decimals like this, with a line above the number that repeats. I also want you to come down here and black out all of these, because you will not ever see this with a repeating decimal. Never, ever, ever. That is not even, to me, that is not even mathematically correct. So we are going to just mark those out. But what they're trying to show you is that that does go on to infinity, but that ... is something totally different that we use to represent non-terminating, non-repeating decimals, which is what you will talk about in 8th grade. So that ... does not, I repeat, does not go with terminating or repeating, or goes with repeating decimals. All the following are examples of repeating decimals. Rewrite each using the repeating line. So to rewrite this, we would rewrite this 2.8 with the line over the 8, showing that the 8 is what repeats. This would be 7.12, because the 1, 2 is what repeats. Negative 10.18, and the 8 is the only thing that repeats there. And 0.123, and the 1, 2, 3 is where you're going to get your repeat. Okay, so all of these are what show that repeat. That's how you show that that's, you don't have to write that long decimal, you just show it with the line. All right, and then we have rational number, and we know we've already talked about rational numbers, but we'll go ahead and talk about this again. Whose decimal form either terminates or repeats, a number that can be written as a ratio or fraction. So we've already discussed rational numbers. We know that they are numbers that can be written as a fraction. A rational number can be written as a fraction or a ratio, okay? Circle or highlight the rational numbers in the list below. So, negative 21 is a rational number. All of these are rational numbers. This, we're going to mark it out because we're going to say that's not because of this. And I know it, and I want you to go ahead now and recognize that that ... is not rational. Not. Ugh. This is not rational. Not rational. Not rational. Rational. Now, I am going to come back up here and erase this, because we're going to mark that out. And if you notice right here, that 444 repeats. So that actually is a rational number, but it is not rational because the ... is there. It is rational because that 4 repeats. That ... goes over here with numbers that are not rational. And I need you to put that in your long-term rememberers. You will not see anything come from us that was not pre-printed, excuse me. Excuse me, that has the ... for rational. You will never see the ... with a rational number. So just know that. Okay. Converting decimals to let's convert this using long division. Now, before we do that, I have these little half sheets for you to help you with remembering how to divide. So our numerator's the ice cream, the denominator's the cone. We draw our division freezer. The ice cream goes in the freezer and the cone stays on the outside. So when you're trying to put a fraction, when you're trying to divide a fraction to get it into a decimal, think about our ice cream, okay? So let's look at that down here. So first we want to read this as 3 divided by 8. So we're going to put divided right here, because the fraction bar is a division symbol. And if you notice, I just kind of extended that fraction bar a little bit. Pull that over. Extended that fraction bar a little bit so that you can make it into a division symbol. Okay? A fraction is always read as the numerator divided by the denominator. Make sure you can see everything. Set up the numerator in the division box. And I'm going to just put in parentheses right here. This is your ice cream. And the division box would be the freezer. Okay? And the denominator, which is our cone, outside the box or the freezer. Divide as usual, using as many zeros as necessary for placeholders after the decimal point. Okay, so what does that look like? Okay, so over here, here's what we got. Let me get me another color because I'm just feeling colorful today. So, here's our ice cream cone. Here's our ice cream. It goes inside the freezer, and the cone goes on the outside. Now, looking at that, 8 won't go into 3, will it? So we've got to put in our decimal. There's a 0 here. It won't go. And we're going to put in some zeros. Now, I'm going to get me something to give me a little bit more room right here to do this, because I write too big. So I'm going to just put me a sticky note right there. Let me write my problem down. Give me just a little bit more room. All right, so again, here's our freezer box. The 8 goes in the freezer and the 3 goes on the outside. The 3 is our ice cream. This is our cone. Here's our ice cream. The ice cream. Sorry, look at what I'm doing. Oops. See, if I hadn't drawn my ice cream cone, look at what I would have done. My ice cream goes in the freezer and my cone goes on the outside. If I hadn't drawn my cone, I wouldn't have known what to do. So, put your decimal in. Decimal's always in the back pocket of your whole number. Decimal's always in the back pocket of your whole number. There's a 0 there. Put in, let's go ahead and put in about 3 zeros. Just to see what we're going to have to do, because we don't know how far we're going to have to go. We're going to go till it stops or terminates. It stops or repeats. So we got to keep going until it stops or repeats. So 8 into 30. 8 times 4 is 32. So 8 times 3 is 24. 3 times 8 is 24. Do our subtraction. That's 6. Bring down that 0. So it didn't stop, so we got to keep going. 8 into 60. 8 times 7 is 56. Subtract. Bring down that 0. Now, because our standard says that our standard says exactly, I'm going to read it to you. It says, convert a rational number to a decimal using long division, which means you're going to have to show all of this division. There is no calculator. 0, 0, zilch, not a calculator. And I'm going to be looking for all of this division, okay? 8 into 40, we'll go 5 times. 5 times 8 is 40. So look at there. We got our 0 denominator. So this is a terminating decimal. So 3/8 equals 0.375 as a decimal. And it is terminating. It is terminating because of this 0 right here. It stopped. It is terminating. And we said that our terminating was red. All right. It is terminating. All right. So here's our reference sheet. Now, this reference sheet, I'm going to just fill this in. And I want you to look in Google Classroom and copy it. Because these are some decimal conversions that if you learn these, you won't have to do that long division. You will just know, okay? These are some things that you just need to know. But let's come on over here to example 1 and look at what it says about converting rational numbers to decimals. Convert the mixed number below to a decimal. So let's see what we have to do to this. To convert the fraction portion, it says convert the fraction of the mixed number to a decimal using long division. The whole number, this will also be the whole number in your fraction, in your answer. So we're going to have 2 point something because we've got 2 1/3. What we've got to do now is convert this, okay? We've got to convert that. So I'm converting. I've got to take my 1/3 and convert it, right? So here's my cone, here's my ice cream, and here's my freezer. The ice cream goes on the inside, the cone goes on the outside. Put my decimal in because I know I'm going to need some. And 3 will go into 10 3 times. 3 times 3 is 9. 3 will go into 10. Look at there. We've already got our repeat. Okay, guys. My phone did something crazy, so I already have filled this in for you. Convert the fraction portion of the mixed number to a decimal using long division. The whole number from the mixed number will also be the whole number from your decimal. Since the fraction is negative, it will also be, the decimal will also be negative. So I picked up my -4 over here and brought it over here and went ahead and made me my decimal. So I'm going to have, excuse me, guys, -4 point something. So I've got to change that something to a decimal. And that workspace is a joke for me, so I'm going to come right here and make me a little workspace. And then, so we're converting 1/5. Here's my cone, here's my ice cream, here's my freezer. That goes on the inside, this goes on the outside. Give myself some decimals to work with. Put my decimal in here. 5 will go into 1 0 times. 5 will go into 10 2 times. 5 times 2 is 10. 0, look at there. We're already there. So, move that out of the way. 4.2. -4.2 is the same thing as -4 1/5. All right, I want you to come right here on your paper. Draw me a little smiley face so I know that you watched my video. And then I want you to try converting these. Practice using these. And we, tell you what, we'll do a couple and then you're going to finish this up, okay? We'll do a couple. I'll do number 1 and number 5. How about that? number 1 and number 5. And I'm going to tell you a trick about number 5, and you're not going to have to do it. So, actually, number 1 is the same way. All right, let me tell you a little something. It's not on this paper. It's not on this paper. But what I want you to write down right here, fractions with a 9 in the denominator. Just draw me an arrow. Draw an arrow. All right, so fractions with a 9 in the denominator. To make a decimal, the numerator repeats. I'm going to tell you what that means. In other words, if there is a 9 in the denominator, look at here. There's a 9 right there. You do not have to do that long division. If you memorize these so that you don't have to do the long division, like 2/4 is 1/2, and we know 1/2 is 0.5. 3/6 is 1/2, and we know 1/2 is 0.5. We know that 1/3, you should memorize these. 1/3 is 0.3. 2/3 is 0.6 repeating. 3/3 is 1 whole. 1/2 is 0.5. All right. There are all of those, but with 9s, the decimal for a 9, the decimal for 5/9 is 0.5 repeating. And I will show you on the calculator just so that you can see that I'm telling the truth. I'm going to put 5/9 in here. Look at there. The 5 repeats. Watch this. 1/9. The 1 repeats. The numerator is any fraction with the 9 in the denominator. The decimal is just the numerator repeating. 2/9. So 2/9. The 2's repeating. So you don't have to do that division. Don't even attempt it. So this as a decimal is going to be 3. There's a 9 there, so I know it's going to be 0.5 repeating. Look at number 5. 4/9 as a decimal. There's a 9 there, so I know it's going to be 0.4 repeating. Because that 9, any fraction with a 9 in the denominator, to write it as a decimal, it's just the numerator repeating. This means that the decimal repeating. This means the decimal and so doing these writing numbers as terminating and repeating decimals doesn't necessarily mean you have to do the long division if you memorize the fractions and memorize the tricks. All right, so let's do number 2. So we're going to have to do that one the long way. All right, so this whole number right here is going to be the whole number in our decimal. So we're going to have 10 point something. So we've got to take our 7/8 and convert it. Well, here's my ice cream. Here's my cone. That goes inside, this goes on the outside. I don't know why I keep writing that in the middle. I need to move it over. Put me some zeros in. Go ahead and put your decimal and a few zeros just in case we don't know what's going to happen. So 8 will not go into 7, but 8 will go into 70. 8 times 8 is 64. That's a 6. Bring down your 0. 8 will go into 60 7 times. 7 times 8 is 56. Bring down that 0. 8 will go into 40 5 times. 8 times 5 is 40. We got a 0 remainder. So this is our decimal 875. Okay. You have 3 more to do right here. And then over here, you have to look at what they did and explain how they missed it. What I want you to do is cover up what they did. Do not look at their work. I want you to get you a piece of paper and I want you to do the work. You do the work and then come back and look at what they did and compare what your work is to their work. That's what I do when I grade your papers. That's why I have all my keys, because I do all of the work and then I can look at your paper and compare your work to my work. And so I don't want you to look at this. I want you to take this problem, write it on another piece of paper, work it, come back and compare your answer, see what they did, and then decide, did they set it up wrong? Was it a work or calculation error? Was the final answer wrong? And then I want you to explain what they did. So down here in your workspace is where you could do your work, and then you're going to compare. But do the work first. The only way to really find somebody's answers, to check somebody else's work, is to do the work yourself. All right? So there you go. That is our converting rational numbers to decimals, and we will continue this. We'll have a couple of days of this, and then we're going to get ready for our unit test. All right.